you ready? Let's learn some math. Math, 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 math. Math, 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 math. Math, 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 math.
Come, take a journey with us each Monday from 5:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.
Hello everyone. Welcome to another episode of Math Matters. I am Shoya Hurst.
And I am Shaka Grant, and we will be your presenters for today.
Now, while the past episodes focus on assistance for secondary school students, we'll take some time over the next few episodes to help our primary students review before the national assessments.
That's right. Mrs. Hurst and I are going to take some time today to help you review the topics of perimeter and area.
So get ready. Grab your books,
Your pencil,
your ruler,
and perhaps your calculator too.
and let's jump right in.
Are you ready? Let's learn some math. Math, 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 math. Math, 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 math.
Great, so now we're all set. So let's begin by taking a look at perimeter. What is perimeter? Perimeter is the distance around the outside of a 2D shape. It's like walking along the edge of a playground, or perhaps in our case, a playing field. Now the perimeter tells us how long the boundary of a shape is. Let's take a look at some examples. Remembering that perimeter is the distance around a shape, we can find the perimeter of a shape by adding together all the sides of a shape. Look at this equilateral triangle, for example. It has one side being 4 centimeters. The perimeter would be the total of all the sides together. Since it's an equilateral triangle, you should remember the properties. That's right. Each side will also be 4 centimeters because they're all equal. So the perimeter would be 4 centimeters plus 4 centimeters plus 4 centimeters equals 12. However, our answer is not just 12. Always keep this in mind, that the units used for the shape are the same units used in the perimeter. So our final answer would be 12 centimeters. We can also find the perimeter for circles and other polygons, which are simply those shapes with straight sides. So those would include our triangle, quadrilateral, pentagon, hexagon, and even the octagon. All these are polygons that we can find the perimeter for because they have straight sides. Now you've been learning quite a bit about the parts of a circle in class. In this case, the perimeter of a circle is known as the circumference. To find the perimeter of round or circular shapes, there's a special formula that we have to use. But you'll learn more about that when you get to secondary school. For other polygons, we can simply just add the sides together. This hexagon has dimensions of 4 centimeters on 2 sides and 3 centimeters on 4 sides. To find the perimeter, we simply add all the sides together. 4 centimeters plus 4 centimeters plus 3 plus 3 plus 3 gives us a total of 17 centimeters altogether, and that would be our perimeter. For this quadrilateral, known as a trapezium, we follow the exact same steps. By adding all the sides, we can find the perimeter, and in this case, we will simply add 10 meters plus 16 meters plus 21 meters plus 12 meters to give us a total of 59. But remember, not just 59. That would be 59 meters altogether. Now perhaps you may be wondering, how is perimeter connected to the real world? I just want you to remember that the whole idea of perimeter is not just limited to shapes on paper. We can actually see many examples all around us in our everyday lives. So for instance, most of our yard spaces or many properties that we may be familiar with have various types of fencing around them. Knowing how much fencing wire or the number of blocks needed to construct a concrete fence, that's an application of perimeter. Take a look at the border around the pictures that we're seeing here in the form of the picture frame. These too are an example of perimeter. In an event, we can have a 4x6 picture frame, a 3x5, 8x10, numerous dimensions that can give us a picture frame, and those an application of perimeter. Now observe this track and field. Does it look familiar? That's right, it's the Yasco playing field, and that is surrounded by a track, which is also an example of perimeter. Even jewelers use some aspects of perimeter. Sometimes in a diamond ring, there's a thin border of gemstones surrounding the main diamond in the ring. This helps it to look larger than it actually is. That too is an example of the application of perimeter. Now we've seen how perimeter can be useful in the real world. We're going to take a break, and when we return, we'll see its application to rectangles. We'll be right back.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofelucation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofelucation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back. Let's dive into the application of perimeter to rectangles. Rectangles have both length and width. When finding the perimeter, we can add length plus width plus width. Or perhaps you're more familiar with the formula of 2 times the length plus 2 times the width, or even 2 times length plus width. This is the formula that we will use to help us find the perimeter of a rectangle. Take a closer look at this rectangle. What would the perimeter be? We know that the properties of the rectangle suggest that opposite sides are equal. So that would mean that this side is also 24 inches and that side is also 13 inches. We can then add all 4 sides, or just apply the formula of 2 times length plus width, and that would give us 2 times 24 plus 2 times 13, a total of 48 plus 26. And when we combine those totals together, we have a perimeter of 74 inches. So now let's practice an actual exam question. Ms. James asked the class to create rectangular posters about recycling. Each poster should have a perimeter of 40 centimeters. What are the possible dimensions the students' posters can have. Now, we're given some information before we begin to solve this question. Here we are seeing that they have to be rectangular, 1, and they must have a perimeter of 40 centimeters. So how do we go about solving a question like this when we don't have the dimensions but we are given the perimeter? I'll walk you through those steps. When we have just the perimeter and we're asked to find the dimensions, these are the steps that we can take. Our first step is to divide the perimeter by 2. In this case, we're going to divide our perimeter of 40 centimeters by 2. Now, if we had the dimensions and not the perimeter, we would simply multiply by 2. But in a case like this, we only have the perimeter and we need to find the dimensions. So we do the opposite, which is division. When we divide 40 by 2, we are left with a quotient of 20. Now, let's go on to the second step, since we've done our division. In step 2, our task is to determine the pairs of numbers that when we add them together, they give us the quotient that we just found. Keep in mind, we did our division, 40 divided by 2, and we got a quotient of 20. So think about it. Take some time. What pairs of numbers, when we add them together, will give us 20? Think on it for a second. Ah, excellent! 10 plus 10, that's certainly 1. Any more? I like that one too. 8 plus 12. And we can keep going. 14 and 6, 9 and 11, and 15 plus 5. Certainly, you're on a roll. These pairs of numbers, when added, give us a total of 20. And we can now move on to using these as the dimensions for our rectangle. When we would have added the numbers, we are seeing that we arrive at the quotient of 20. These are the dimensions for the rectangles that the students can have for their possible poster designs. We're only going to take a few, and we'll see if we truly get back that perimeter of 40 centimeters. So let's try. We're going to begin with the 10 plus 10. This means that both the length and the width would be 10 centimeters. But pay close attention to this. What do you notice? That's right, we have a square. Since it's a square, all sides would then be 10 centimeters. The perimeter, if we're going to follow the steps, would be 10 centimeters plus 10 centimeters plus 10 centimeters plus 10 centimeters, and that gives us a total of 40 centimeters. So the students will be able to design a poster in the shape of a square meeting the requirements. Let's try another pair. This time we'll use 9 plus 11. This gives us a true rectangle. As a result, the length of the poster would be 11 centimeters being the longer side, and the width would be 9 centimeters, the shorter side. If we are to go through applying our formula of 2 times length plus width, we'll see that we now have 2 times 11 centimeters plus 2 times 9 centimeters, giving us 22 plus 18, and when added together, we have a perimeter of 40 centimeters. So the students will be able to have a poster designed in this type or form of rectangle as well. These are just some possible dimensions they could have to meet the requirements of 40 centimeters for their poster. You've certainly been awesome mathematicians solving these perimeter problems with me. We'll now take a break, and when we return, Ms. Grant will walk us through the topic of area. We'll be right back.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofelucation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofelucation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back, everyone. You've learned quite a bit about perimeter, and now we'll take a closer look at area. Area is the amount of space taken up by a 2D shape. Think about all the spaces around you. The space taken up by a football field, the space taken up by your desk at school, and even the space taken up by the paper you're writing on as we speak. All those spaces can be calculated by finding the area. What is the difference between perimeter and area? Very often, it is sometimes difficult to remember the differences. This is one way of thinking about them. Perimeter is the space outside of a shape, while area is the space taken up inside of the shape. So how can we connect area to our everyday lives? I'm so glad you asked. Once the floor of a room has to be tiled, we use the concept of area to determine how many tiles we will need and even how they can be arranged. Are you thinking of becoming an interior designer? Great. Often, interior designers have to use the concept of area when selecting area rugs or carpets in designing a room. Artists also use the application of area when drawing or painting, whether it is a design on a wall art or simply on canvas. They have to consider the area of the surface they are using. Let's try some application. There are two strategies that we can use to find the area of a shape. The first strategy has to do with counting the unit squares. Yes, take a look at these two shapes. We can find the area of the blue figure by counting the number of squares it takes up. Let's count them together. 1, 2, 3, 4, 5, 6, 7, 8, 9. Awesome job. Let's count the amount of space taken up by the orange shape. Let's count them together. 1, 2, 3, 4, 5, 6, 7, 8, 9. Awesome. But what did you notice? These shapes have the same area. They are both 9 square inches. We know this because we counted the number of squares to determine the space the shape takes up. Sometimes the unit may be in inches, miles, feet, or even centimeters. In that case, we would then state the area as square inches, square miles, or square feet. Never forget to square your units. It all depends on the units we are working with. Look carefully at this triangle. What is the area? We can find the area by counting the squares. Let's count them together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Awesome. We just counted all whole squares. Now, if you take a closer look, you will see that there are some half squares. We know that 2 halves make a whole. So let's continue to count the rest of the space that the triangle takes up. Half plus half, that gives us a whole. So now we have 16 whole squares. Half plus half gives us another whole square. So now we have 17 whole squares. And half plus half gives us another whole. And now we have 18 whole squares. But remember, don't forget to square your units. So the area of the triangle is 18 squared units. The second strategy is to multiply the length by the width of rectangular shapes. Let's take a closer look at the area of rectangular shapes. Unlike the perimeter formula, when finding the area, we multiply length by width. At times, we can use L to represent length and W to represent width. So you will often see the formula A equals L times W. Look at this shape. It has a length of 4 centimeters. If you look closely, we will observe that it is a square. Now we all know the properties of a square. All 4 sides are equal in length. Therefore, if the width is 4 centimeters, all sides will have a measure of 4 centimeters. What then would the area of this square be? We can use the area formula to help us find our answer. Length times width. Since it's a square, we can also say side by side. Get your calculators ready. Area would equal 4 centimeters times 4 centimeters, which will give us the area of, correct, 16 centimeters squared. Now we know the formula of finding the area. Let us apply this formula to this question. It will be an exam type question. Justin wants to make a screensaver for his new computer. The screen is 32 inches long and 18 inches wide. What is the area of the screen? Using the area model, we will multiply the length by the width. We will multiply 32 inches times 18 inches, which gives us the total area of 576 square inches. And there you have it. Finding the area. Wasn't that easy? Don't go anywhere. We'll be right back after these messages.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofelucation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofeducation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back. Now that we reviewed perimeter and area, we have a challenge question for you.
Mr. John is thinking of creating a garden with an area of 36 square feet. He wants it to be in the shape of a rectangle. Each side will be longer than 1 foot, and the length and width will measure whole feet.
Now that simply means that we can't have decimal dimensions in our length and width. So part A is asking us to draw 3 different rectangles that will represent Mr. John's garden, showing length and width. B is saying once we've done that, we now need to calculate the perimeter of each rectangle drawn in part A.
Here is your chance to practice and submit your responses. Please send your answers to mathmatters268@gmail.com. That is mathmatters268@gmail.com.
We look forward to hearing from you. And our top 2 participants will have a chance to win a prize. So be sure to participate.
Thank you for joining us.
And be sure to tune in next week when Miss Grant and I will focus on the topic of time. Have a wonderful evening.
Learn some math.
Come, take a journey with us each Monday from 5:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.